So 7th grade today, we're focusing on this formula. S equals n minus 2 in parentheses times 180 degrees. This formula is used to find the sum of the total of all the angle measurements in a polygon. So let's look at an example, because one of the things you're going to have to do is you're going to get a polygon. And I always love it when I get to show off my artwork to all of you. As always, we're going to pretend that those lines are perfectly straight. So essentially there we have a upside down L. And our job is to figure out how many degrees all of the angles in this polygon would add up to. So I want to make sure, first of all, we understand we have an angle here. We have an angle here. We have an angle up here. We have an angle right here. We have an angle right here. And we have an angle right there. Okay? So all of those angles, it looks like there's 6 of them total. We can figure out how much they add up to by using this formula, S equals n minus 2 times 180. So the first thing we need to figure out is what n equals. Now, S represents the total number of degrees. This is ultimately what we're trying to find is S. That's the total number. N in this formula represents the number of sides the polygon has. So the first thing I have to do is figure out how many sides the polygon has. So I have 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. And that makes sense because there's 6 angles. When it comes to polygons, the number of sides corresponds with the number of angles. So we talked earlier a minute ago that we had 6 angles. We also have 6 sides. So 6 is what gets plugged in here. So the first thing I'm going to do is 6 minus 2. 6 minus 2, that's not hard. That gives me 4. So I always take, order of operations tells me I do what's in parentheses first. So 6 minus 2 is 4. Then I'm just going to take 4 and multiply it by 180. Okay? So what I'm going to do here is I'm going to take 4 times 180. You can just plug it into your calculator, but I'll go ahead and just do it right here. 4 times 0 is 0. 4 times 8 is 32. Put the 2 down, carry the 3. 4 times 1 is 4, plus 3 is 7. 720 degrees. This polygon has 720 degrees. So that's not too difficult. You can handle that. So let's look at the next part of using this same formula. S equals n minus 2 times 180 degrees. So we're going to come over here, and we're going to get something that looks like this. Okay, let's get a little figure here. That's an interesting little figure, but there it is. I'm going to say that this angle right here is 25 degrees. I'm going to say that this angle right here is 137 degrees. I'm going to say that this angle right here is 155 degrees. I'm going to say that this angle right here is x degrees. So this is a different section, but it's utilizing this same formula, S equals n minus 2 in parentheses times 180. So we go back to this figure. So to be able to solve for x, common logic should tell us, well, I need to figure out how many degrees are in the entire thing total. So I think to myself, well, how am I going to figure out how many degrees are supposed to be here total? Okay, because really what I should be doing is adding all 3 angles that I know and subtracting it from how many degrees there are total. But I don't know how many degrees there are total. So I need to use this formula, S equals n minus 2 in parentheses times 180. First thing I need to do is establish n. N, remember, represents the number of sides the polygon has. I look at this. This is a clear quadrilateral that has 4 sides. So I can kind of mark those. 1, 2, 3, 4. 4 sides. So for n, I'm going to plug in 4. So I'm going to do 4 minus 2. I think 4 minus 2 is 2. So I'm going to have to come down here, and I'm going to do 180 times 2. 2 times 0 is 0. 2 times 8 is 16. Put the 6 down, carry the 1. 2 times 1 is 2, plus 1 is 3. I get 360. But my answer is not x equals 360. It would be very easy to be in a rush and just say, oh, the answer is 360. But no, remember, that's not what we're solving in this section. What we're doing is we're solving for x. So all 4 of these angles combined equal 360. So what I have to do is I have to take the 3 angles that I know, 137, 155, and 25, and add them together. So I'm going to do that. 137, 155, 25. I'm going to add all those together. 5 plus 5 is 10, plus 7 is 17. Put the 7 down, carry the 1. 1 plus 3 is 4, plus 5 is 9, plus 2 is 11. Put the 1 down, carry the 1. 1, 1, and 1. Make 3. I get 317. Once again, it would be easy to rush and think, well, oh, x equals 317. No. X is just going to be the difference. So I've got to take my 360, and I'm going to subtract 317. Can't do 0 minus 7. So I'm going to borrow from the 6. I'm going to make it a 5. My 0 is going to become a 10. 10 minus 7 is 3. 5 minus 1, I think, is 4. 3 minus 3 is nothing. And so I find that x equals 43. And that's my final answer. The last part of what we're doing, and I'm going to refer here over to the book. I'm going to look at these figures right here. And I'm just going to talk about these a little bit. Okay? This last set of what you're doing talks about tell whether the polygon is concave or convex. Actually, it puts convex first, then concave. Well, when a polygon is convex, that means that you cannot connect 2 corners of it by drawing a line outside. For example, number 9 would be considered convex because I can't connect any of these points by drawing a line outside of the figure. The only way I can connect 2 points is by drawing a line through the figure. Okay? These 2 lines are connected, but that's part of the figure. These 2, that's part of the figure. If I connect those 2, the line goes through the figure. If I connect those 2, the line goes through the figure. So I look at that, and that is a convex figure, convex polygon, because I cannot draw a line outside of it connecting. Now, numbers 10 and 11 are both concave polygons. I know they're concave because just like in the convex, this first one where I could not draw a line connecting 2 endpoints in number 9, I can do that in number 10. Clearly in number 10, I have this little Pac-Man looking guy. I can connect that point there with that point there by drawing a line right there. I'm not actually going to draw a line in my book, but if I did draw a line, I would draw it right there. That is outside the figure. Another easy way to remember concave is that the figure caves in. Concave, the figure caves in. Clearly this figure caves in, allowing you to connect those 2 lines. Same thing with number 11. I could connect this point and this point, that point and that point, that point and that point, that point and that point. I can connect those points outside of the figure. The figure caves in. That makes it a concave figure. All right, we'll see you in class time, 7th grade. Have a good day.